To wrap up this module, I wanted to talk just a little bit about dating methods and how archaeologists can say exactly or about how old something is. Obviously, building chronologies and saying how old something is really important in archaeology. It really is important to that goal of reconstructing past lifeways, of building these cultural histories of different areas. And so we can't just ignore how this happens. And so I just want to give a little brief overview so that as we're talking about all these different things in prehistory, that you have a better understanding of where these dates are coming from and how archaeologists have found them. So the first thing that we need to know is that there's really two major types of dating, which is there are direct dating methods and there are indirect dating methods. So direct dating methods are always preferred because this is where we can date archaeological evidence directly. So if I hand you an artifact, you can tell me based off of that artifact itself using physical methods or chemical methods or biological methods or whatever else, that you can say this artifact is X amount old. The problem is that most archaeological artifacts cannot be directly dated. And this is because a lot of our dating methods, like radiocarbon dating, rely on the fact that these artifacts have carbon in them. A lot of these things require carbon, and the only things that really possess a lot of carbon in that way are things that used to be alive. But a lot of artifacts made out of stone, clay, like pottery, things like that, don't have any carbon. And so a lot of the times those things can't be directly dated. The other thing is that a lot of direct dating methods like radiocarbon are destructive. You have to like burn up a small little part of the artifact in order to date it directly. And so we can't really do that either. So a lot of the times as archaeologists, we have to rely on what we call indirect dating methods. And this is where we estimate the age of the archaeological evidence by dating something else. So for example, perhaps we find a stone tool that's right next to something that has carbon in it, like a piece of animal bone or something. And then you date that other artifact. And then you say, because these two things are found right next to each other, because they are associated with one another, that we then can date them. We can say that this stone tool is about the same age as that. Because we have an age for that, we now have an age for this stone tool. Right? That's why context and association are also really important for dating. But for indirect dating, we're not actually dating the object itself. We're dating something else around it that can be dated, and we're finding it. Right? So that's one distinction we have to make, is the difference between direct dating and indirect dating, and recognize that most archaeological materials are dated through indirect dating. The other distinction we have to make is the distinction between relative dating and absolute dating. A lot of the times what we want is absolute dating, and this is where we determine an age for the objects themselves. And so this is where we say an object is 3,000 years old, right? So it gives you an absolute date. It gives you a date on the calendar that this object comes from. That's preferable. However, again, even though it's preferable, most archaeological artifacts are not dated this way. Instead, we often have to rely on relative dating. And that is that we have to make estimates of an age based on associations or comparisons of the item with other things found at the site, and how we can determine if things are older than younger than others. So for relative dating, for example, we can use stratigraphy, and we'll talk about that in a second. But you can say, okay, this is 10 meters down below the ground surface or whatever, but that doesn't give you an absolute date. Instead, you often have to say, okay, well, we know that it's younger than this and older than this, so we're going to get something in the middle. So for example, perhaps there was a volcanic explosion, and so you get an ash lens, and that ash lens can be directly dated. And then 1,000 years later, there's another volcanic explosion, and there's another ash lens, which can be directly dated. And we find an artifact in the ground between those two ash lenses. We now know that it's younger than this one, but older than this one. So we know that it falls somewhere in that 1,000-year span. We don't know what the exact date is, but we do know that relative to those two things that can be directly dated, that this falls in the middle. So that's relative dating. We can't give you an absolute calendar date. We can just tell you that it is younger or older than something else. So as I was just saying, the main relative dating method is stratigraphy. And when we're talking about stratigraphy refers to the layers of sediments, debris, rock, and other materials that form or accumulate as a result of natural processes, human activity, or both. So essentially, there are layers in the ground, and you can try to determine relatively how old something is based on which layer in the ground it comes from. Stratigraphy relies on two really important laws. First is the law of horizontality. And this is just the assumption we make as humans that as soil and dirt accumulates, that it will happen horizontally and that one layer of dirt will start to accumulate on another layer of dirt. All right. And because of this, we can have the law of superposition, which says that younger soils, younger dirt is on top and older dirt is on the bottom because they're layering on top of one another. You know, the classic example is when you make a cake, a layered cake. And so what's the oldest layer? Well, it's that bottom layer of cake because that was what you put down first. And then it's that next layer of icing is the next oldest because what you did second. And then you put that other layer on and then another layer of icing and then another third layer and then maybe the top icing, right? So the top icing is the youngest because it's on top. It's what you did last. And the first layer of cake is the oldest because it's what you did first. Stratigraphy works the same way. So if we look at this image here, we can look at these stratigraphic layers. This layer down here with this arrowhead in it is the oldest layer, right? And then the next oldest layer would be this hand mirror with the broken glass, all right? We don't know how old either of these objects are just because of stratigraphy. But what we do know is that this mirror with the broken glass is younger than the arrowhead because it is in the layer right above it. Then we got this next layer with this fancy pot. Then what we see is this is where it gets complicated. These bones are probably around the same age as this hand mirror because you dug into the layer before this layer came in. But if we want, we can just work our way up. And so oldest working all the way up to youngest. And that's how stratigraphy works. Right? And so by looking at the sequence of soil layers from earliest at the bottom to youngest at the top, we can construct a relative chronological sequence of events. This is cool and it is important because you know, we now can say which objects are older than others, but do keep in mind that we have to be careful that this isn't an absolute dating method. Unless something in one of these layers can be absolutely directly dated, that is that we can find a calendar date, we only can say that one object is younger than another. Now, luckily, usually we can say one artifact is directly older. We can directly date one, and then that'll give us a year in which we can work around. So we can now say, okay, this one artifact we were able to directly date, yes. And we were able to do an absolute dating method and say it's 3,000 years old, yes. So then based on the stratigraphy, we can then say, okay, well, at least we know all the objects up here are younger than 3,000, and all of these older objects down here are older than 3,000. And hopefully, as we keep digging, we can find more and more objects that we can directly date. I do want to note, though, that the date that we're getting from this is the date of discard, not the date of creation or use. This is when the object was finally thrown away, when it stopped being used, not when it was first made or first used. And some objects are going to be passed down for hundreds or thousands of years. And because of that, we have to be careful about when we date things. So just to note that whenever we find something in an archaeological record and we date it, we are saying this is when it was stopped being used. This is when it was thrown away. Some of you probably, or your parent, you or your parents probably have heirlooms in your family that have been passed down from generation to generation. If you threw that away today and you threw it in the garbage, an archaeologist would be able to identify the date that it came from there. But that object may have been made hundreds of years before then. So just a thing to keep in mind as we're dating some of these objects. Another relative dating method that we have is seriation. And seriation is when we order objects chronologically based on their qualities or attributes, right? And so this is kind of a complicated thing, at least it's hard to explain, but once you get it, it's pretty simple. But essentially, seriation says that artifacts produced at the same time will tend to resemble one another, but that over time, the style of the objects will change. And that eventually, small differences will accrue. And if we put things in order based on those small differences, we can actually say what things are older than others. This is easiest to explain with a really quick example of looking at iPhones. So if I gave you all these iPhones and I didn't put them in any kind of order, but I just threw them at you in just a random array, a random display, and then I said, put them in order, you could probably do a pretty good job of it. And the reason you can do a good job of it is because Apple has made very small, gradual changes to the iPhone over time. Over time, it has generally gotten bigger. We can see when they got rid of the home button. You can probably look for when they got rid of the headphone jack, when they moved buttons around, when they changed the look of the home screen. And what you can do is put these in order because they're these small incremental differences. So, and that is at the end of the day how these types of things work. So we can do the same thing archaeologically. So objects that resemble one another tend to date right around one another. Objects that don't look alike at all, like this first iPhone over here and this last iPhone over here, tend to look radically different from one another, right? And we can do the same thing with like pots, right? So you can say, okay, well, this pot looks about the same as that other pot, but it just has a slight difference. And you can be like, okay, those are probably dated right next to each other. And then we notice this next difference added onto that. Okay, that's probably the next youngest, and the next youngest, and the next youngest, and the next youngest. And so you can put these things in order based off of just this very simple idea that small changes in style are going to accrue over time, and that the things that resemble one another probably date closely to one another, right? So at the end of the day, this is what seriation is, right? There's two different ways to do seriation. What I was talking about is stylistic seriation, but you can also do frequency seriation. Don't worry about anything that's on this slide. This distinction is not super important for this class. What is important is that you understand how seriation works, which is that it's all about accrued differences through time. Now we can start moving on to some of our absolute dating methods. Now that we've talked about seriation and stratigraphy as examples of relative dating methods. And the first absolute dating method that we can use is called dendrochronology, which is being able to get an absolute calendar date based on tree ring data. And dendrochronology is based off this idea that many trees produce a growth ring each year. And the growth rings of these can actually change over time. So some years you're gonna have really big rings because you've had a really wet, really good year for growth. And some years you're gonna have a really shitty year, it's really dry, there's not a lot of water. And so you're gonna get a really small ring. And then what we can do is we can actually line up the rings of these trees in order to create regional sequences. So for example, if a prehistoric person built their house out of tree trunks, you can actually take those tree trunks and you can actually lay them across and say, okay, let's count the tree rings back in order to get some dates, right? And we have these really long sequences based off of years in which they're big, in which they're small. And then what we'll do is we can actually do radiocarbon dating on some of these rings in order to get absolute dates. And then from that, you then just have to count rings to know how old that tree is. And that way you don't have to keep doing chemical analyses because radiocarbon dating isn't cheap. But if you can just if you just know what each ring's year is and you can look that up in a database, which we can, all you have to say is pull your thing down and be like, this is how old it is based off the tree ring data, right? This works really, really well in areas like the American Southwest where trees were used for building and where environmental conditions made it so that wood preserved well over time. Doesn't work so well in other contexts, and it only works well back for the past few hundred years. Our sequences are really good for more recent sites, but once we get into deep prehistory, wood isn't preserving, we don't have really good sequences for this. But it's a really cool way where you can just be like, okay, well, this person used a tree trunk at the site, let's count tree rings and then count how back, you just keep counting back how many years you go, and that will tell you how old the site is. And it's really cool. And we have these really great sequences of tree ring dates. The other really big absolute dating method is radiometric dates. And radiometric dating is any dating that's based on the natural rate of radioactive decay in archaeological materials. This works because a lot of radioactive materials actually decay at a consistent rate, which is what we call a half-life. So we can say that, for example, as one element decays into the next, the amount of time it takes for half of that element to decay into the other element, we call a half-life. And that's usually at a predictable rate. So what we can do is we can just measure the amount of radioactive element and the amount of its stable decay product to determine how many years have passed since the decay process began, right? So the most common dating method of this is C14 dating. So you look at how much C14 versus C12, which are two different variants of carbon, are in a material. And the more that C14 decays into carbon-12, the more that we know that more time has passed. And so you can measure this at a pretty predictable rate. and then actually get a real calendar date for how old that object is. Very cool. But again, it can only usually be done on things that possess carbon, and that is living things or things that used to be alive. Okay, so those are all the basic ways of dating sites. So you should walk away having the basic understandings of stratigraphy, seriation, dendrochronology, and a very basic understanding of how radiometric dating works, which is just that you have unstable radioactive elements that are decaying into stable elements, that this decay process occurs over a time that is predictable and easy to predict. You can then measure how much of how much of each element are in a thing you find in the archaeological record, and based on that, you can say this is how old it is. Right? We don't have to know anything more about that in this class. This is not an archaeological methods class. It's also not a chemistry class. So we're just going to keep moving on from here. But that's it for archaeological methods. We are now ready to start talking about actual prehistory, which we will begin in the next module. But feel free to come to office hours or email me if you have any questions or concerns about anything we talked about in this module.